This is a physics-related problem. We know that the kinetic energy is given by this formula over here, a half times the mass times the velocity squared. So m is the mass, k is the energy, and v is the velocity of the moving object. So we have a moving object with mass m moving with a velocity v. And we would like to see what happens to the kinetic energy if I double the velocity of the moving object. So I want to compare kinetic energies in the case where I start from a velocity v and I double the velocity. So v prime, let's assume I have v prime, it's not the derivative, the prime, equals 2 times v. So I have my mass here, mass doesn't change, the object does not change, and my velocity is v prime doubled. So the new kinetic energy is given by this formula. The mass stays the same. So I have the product of a half times the mass times the velocity, the new velocity squared. So I call this relationship 1 and this relationship 2. I divide the kinetic energy, so I find the ratio k divided by k prime. K is the previous, k prime is the new kinetic energy. So I can, these terms, I have v divided v squared, the velocity squared, and the new velocity squared. So this can be written as v divided by v prime squared. I am doubling the velocity, and this is 1 divided by 4. So the ratio of the two kinetic energies is 1 divided by 4. In other words, k prime equals 4k. Which means that when I double the velocity, the new kinetic energy is 4 times the previous one, so it's quadrupled. I double the velocity, and my kinetic energy increases 4 times. And this can be written also as k prime greater than k. So I have increase of the kinetic energy. Imagine that you have a vehicle, a car, with mass m. You have a certain velocity moving the car towards one direction. Then you double the velocity, you increase the velocity in such a way that it is double the previous velocity that you had. And what you see is that you take the ratio of the two kinetic energies, and you see that the more velocity you have in your moving object, the greater the kinetic energy will be.